Okay, so for chapter 10, I'm not going to go over all the problems, but I'll try to give you the hints how to solve the problem from chapter 10. Okay, so the first problem is a variable of two population has a mean of 25 and a standard deviation of 16, or one of the population, and a mean of 25 and a standard deviation of 9 for the other population. So actually we are performing hypothesis test for two population mean. So we have the x bar, a variable of two population has a mean of 25 and it's a standard deviation 16. And for this one, we have, oh, okay. So here actually we have mu1 is 25 and sigma 1 is 16 and mu2 is 25, sigma 2 is 9. Okay, moreover the variable is normally distributed, so this one is normally distributed and this one is also normally distributed. So for independent sample of size 16 and 9, so n1 is 16 and n2 is 9. Okay, determine the mean and standard deviation of x1 bar minus x2 bar. So what is the mean of x1 bar minus x2 bar? So mu x1 bar minus x2 bar. We know that this is the difference between the population mean of x1 and population mean of x2 bar. So which is mu1 minus mu2. So that's been 25 minus 25, which is 0. Okay, so the mean difference is difference of the mean is 0. The next one is the standard deviation. Okay, so let me erase this part. Not all the information, because we also need this information. Okay, so we need to find x1 bar minus x2 bar. So this is actually a square root of sigma 1 square over n1 plus, since they are independent sample, sigma 2 square n2. So what is the sigma 1 square? So this is 16 square over n1 is 16 plus 9 square over 9. So that's mean this is actually, if you simplify this, then it will be a square root of 16 plus 9. So square root of 25. So that's mean this is 5. So the standard deviation will be then 5. So this is 5. Let me check the answer. Yeah, that's correct. Okay, so can you conclude that the variable x1 bar minus x2 bar is normally distributed? Yes, we can, because it is given that each of the population is normally distributed. So that's mean the difference is also normally distributed. So this is the correct answer. So yes, x1 bar is always normally distributed because the central limit theorem. No, not really. No, since this must be greater than. Yes, since the variable is normally distributed on each of the two population. Yes, that's the correct answer. So the correct answer will be this one. Okay, so determine the percentage of pairs of independent sample of size 16 and 19 respectively from the two population with the property that the different sample mean is between. Okay, so now actually you need to calculate the probability for x1 bar minus x2 bar. So it is given that you need to actually find this one. So how do you find this one? You need to convert this one to a standard normal distribution, and this one also is standard normal, sorry, z-score. So how do you calculate this one? This is x1 bar minus x2 bar. So the value is negative 10. So negative 10 minus, what is the mean for this one? Mean was 0, right? Mu1 minus mu2. Mean for x1 bar minus x2 bar was 0. And the standard deviation we found 5, right? So that's why this is 0 and the standard deviation is 5 for this one. So this will be 5. And z-score for 10 will be then 10 minus 0, and this is 5. So that's when this is negative 2 and this is equal to. So now you need to look at -2 and 2 and find the in-between probability. I think it will be approximately 95% because within 2 standard deviation. So it should be 95%, I guess. That's not correct. But what you can do, you can, yeah, you can use the Z table in that case. Yeah, look at the Z table. It is not exactly 95%, but it is close to 95. So it's better to look at the Z table, okay? Yeah, 95 if you use the empirical rule. So it would be at least 95. But you need to look at the Z table, okay? Okay, so now we'll discuss the hypothesis test for 2 population mean. So we have all the information and our test is two-tailed test. So since the test is two-tailed test, we need to select the null and alternative. So in null, we always have mu1 is equal mu2. So that's mean the first one is not, A is not correct. How about B? B could be, but it's two-tailed. The alternative is not two-tailed, so it is not correct. How about this one? Yeah, it seems this one is correct. How about the no, not this one, not this one, not this. Yeah, C is correct answer. Okay, so now compute the, now I'll tell you how to compute the test statistic. So since this is, first you need to determine whether you are using the pooled hypothesis test or non-pooled hypothesis test. So when do we use pooled hypothesis test? When we have the assumption that sigma 1 is equal sigma 2. Since it is given that the pooled t interval is appropriate, so we can do t-test in this case. Sorry, pooled t-test. So how do we perform pooled t-test? T observed is equal x1 bar minus x2 bar divided by sp over 1 over n1 plus 1 over n2. So this is how we calculate the pooled t-test statistic. So what is SP? SP is the pooled standard deviation, which is the square root of n1 minus 1 times s1 square over plus n2 minus 1 times s2 square divided by n1 plus n2 minus 2. Yeah, this is okay. So you can look at the formula. So if you look at the formula of SP, you will get this is the square root of n1 minus 1 times s1 square plus n2 minus 1 times s2 square divided by n1 plus n2 minus 2. So that is the formula to calculate SP. Okay, so that's your pooled standard deviation. And you already have the sample size n1, which is 18, and you have n2, which is 18, and x1 bar is 15, x2 bar is 16. Then you will simplify and get the test statistic. Okay, so after that, you can find the critical value, and the degrees of freedom will be here n1 plus n2 minus 2. So this is the degrees of freedom in this case. So you have the test statistics, you have the degrees of freedom, you can find the p-value, or you have the alpha value and you have the degrees of freedom. So alpha is, since this is 90% confidence interval, so alpha is then 10%, which is 0.1. So since you have the alpha value, you can find the plus minus z alpha over 2, which is t alpha over 2, because we are using t-test. So plus minus t 0.05. So from the t-table, you will find the critical value. So you have the test statistics here. You can find the critical value, compare the test statistic and critical value. So if the test statistics falls in the rejection region, so you will reject the null, otherwise we fail to reject the null. Okay, so let me clear all the drawings. Okay, so this is also similar problem. And this is also two-tail test. So I'm not going to go over this one, and you will be using pulled t-test. Okay, so this is also a similar type of problem, and here you will be also using pulled t-test, but this is right tail test. So that's mean your hypothesis is this one. This is the, yeah, this is the correct hypothesis. Yeah, after that, this is also pulled test. So you will be using the same formula to calculate the test statistic. Okay, so if you view an example here, then you can see we have the similar problem. This is also right tail test. So we have the alpha value. See, this is the formula to calculate the pulled standard deviation. Square root of n1 minus 1 s1 square plus n2 minus 1 s2 square divided by n1 plus n2 minus 2. So you can calculate the test statistic. This is the formula to calculate test statistic. So you'll plug in all the numbers and calculate it. So this is 4.5981 for this example. Then you will find the critical value. Yeah, so after simplifying this, we found the test statistics for this example is 1.771. Then you'll calculate the degrees of freedom, which is n1 plus n2 minus 2. So for this example, this is 13 plus 17 minus 2. N1 is 13, N2 is 17, and minus 2. Okay, so which is 28. So to find the critical value, you need to look at the alpha value. Alpha is 0.05 in this case because this is okay, so this is 90%. Yeah, alpha is given 0.05. So T alpha will be T 0.05, which is, and degrees of freedom is 28. So if you look at the T table for 0.05 and degrees of freedom 28, the T value will be 1.701. Okay, so this is the critical value. So now we'll compare the critical value and the test statistic. So what did we find for test statistics? We found 1.771 and the critical value is 1.701. So that's mean the test statistics falls in the rejection region. So we reject the null hypothesis in this case. Okay, so to construct the confidence interval, to construct 90% confidence interval, so you need to use this formula, x1 bar minus x2 bar plus minus T alpha over 2 times, so the standard error, which is SP square root of 1 over n1 plus 1 over n2. So you have to use this formula. Okay, so let me clear all the drawings. This is also similar type of problem, but this is a right tail test. Yeah, this is exactly similar problem. So I'm not going to go over this. And here we have also two type of land, cropland and grassland. And we have the average x1 and sample average x2. We have the sample standard deviation s1 and sample standard deviation s2. It is 4.69 and 4.88. They are very close. So even though it is not given that the population standard deviations are equal, but we can still use pooled test because it is given that we need to use pooled test, or if it is not given, if you look at the sample size, they are very close. So I guess we can still use pooled test if it is not given. Okay, so whether it is right tail or left tail, so we want to conclude that the difference exists in the mean number of species in the two regions. So we want to see whether there is a difference exist. So that's mean this is two-tail test. So we are assuming they're equal, but we want to test whether there is a difference. So this is the hypothesis for in this case. Okay, so now we will calculate the test statistic using this formula. Oh, I'm sorry. Okay, yeah, I think it will work now. Yeah, T observed is this one, where SP is square root of n1 minus 1 is 1 squared plus n2 minus 1 is 2 squared divided by n1 plus n2 minus 2. Yeah, this one. You have the formula, so I'm not going to write it clearly. So you have the formula. You can use the formula from the textbook or from the lecture note. Okay. So then you will calculate the test statistics and critical value. So you'll compare the test statistics and critical value. So if the test statistic falls in the rejection region, we'll reject the null. Otherwise, you will fail to reject the null. So let me clear all the drawings. Okay, so let's go over the next problem. So here we are also given x1 bar, x2 bar, indicate that there is a considered assumption for using pooled t. So here we can also use pooled t interval. So the formula is x1 bar minus x2 bar plus minus t alpha over 2 times sp times square root of 1 over n1 plus 1 over n2. Yeah, this is very simple formula. So you have x1 bar, x2 bar, subtract this, find the t alpha over 2, calculate the sp, which is a square root of this is the formula. Okay, so you get sp from this formula. You have n1, n2. You'll find the t alpha over 2. Alpha is 0.10. That's been 10%. You have x1 bar, x2 bar. Plug in all the numbers and simplify this. After simplifying, you will get a smaller number and a larger number. So that's you'll get two numbers. This is the upper limit, the larger number, and the smaller one is the lower limit. Okay, so the next one. Okay, so let me clear the drawings first. Okay. So this is two-tailed test, and you need to construct the 90% confidence interval. So this is also independent sample. So this is also, but this is different. This is non-pooled t-test. So you have to use this formula to calculate the test statistics in this case. For non-pooled t-test, it will be then x1 bar minus x2 bar divided by a square root of s1 square over n1 plus s2 square over n2. Since s1 s2 are not equal, or you can say mu1 mu2 are not equal, so we cannot use the pooled t-test in this case. So in this case, you have to use non-pooled t-test, and this is the formula to calculate test statistics. So here the difficult part is calculating the degrees of freedom, because this formula is a little complex. Yeah, so you need to calculate the degrees of freedom using the formula for degrees of freedom. Okay, so let me clear the drawings. Yeah, so this is right tail test, and this is also independent sample. This is non-pooled, and this is also is it right tail test or left tail test? I mean number of acute post-operative days in the hospital is smaller than. So this is actually left tail test. So the correct answer will be this one, I guess. Yeah. Then you will calculate the test statistic for non-pooled t-test and find the critical value. So Okay, so when you will be calculating the degrees of freedom in this case, so look at this example. Okay, this is the formula for test statistic in this case. So this is not that much complex, but if you look at the degrees of freedom formula, yeah, this is a very complex formula, right? So you have to use this formula. You do not need to memorize it, but you can keep it in front of you so that you can use this during the exam. Okay, so you'll calculate the degrees of freedom. So for example, if you find degrees of freedom 23.1, you'll consider 24. So you will always, sorry, you will consider 23. You will always round down to the nearest integer. So if you get 23.8, so you'll consider 23 as well. So similarly, if you get 30.6, you'll consider 30, the degrees of freedom. You'll always round it down to the nearest integer, okay? Okay, so let me clear the drawings first. Okay, so this is what are the hypotheses for that? This is non-pull test. This is also similar problem, so I'm not going to solve this one. And this is mu is not equal mu2, so this is two-tailed test. And this is paired sample. So that's mean, okay, so here you the samples are not independent sample. So this is paired sample. So that's mean they are collected as a pair. So they are dependent samples. So in that case, we cannot use the pull test or non-pull test. So in this case, we have to use the hypothesis test for paired sample or dependent sample. So that's mean first you need to calculate the difference. So you need to calculate the difference, which is DI. DI means the difference of ith observation. So 15 minus 13 is 2, 4 minus 3 is 1, 18 minus 15 is 3, 16 minus 10 is 6, 17 minus 13 is 4, 21 minus 22 is -1, and 8 minus 5 is 3. So first you need to calculate the difference of this data and this data. Okay, so then you will calculate the D bar, the sample mean for this one. Then you will calculate the sigma D or sigma D bar or SD, the sample standard deviation of the difference, standard deviation for this one. Then you can use the test statistics. This test statistics T observed is equal. So this is D bar minus the hypothesized value. So in this case, the hypothesized value is 0. So we do not need anything. And then SD, this is the standard deviation, and over the sample size, what is the sample size here? 7 over square root of here it is 7. So this is the test statistic. We can just go over an example. We can just look at an example here. Okay, so let me clear the drawings. Okay, so we want to test whether mu1 is different from mu2, but this is paired sample, so we cannot use either pull test or non-pull test. We have to use the hypothesis test for paired sample. So first you need to write the hypothesis, then you need to take the difference and calculate the sample mean for the difference, which is D bar, and standard deviation for the difference, which is SD, divided by square root of it. This is the test statistic in this case. Okay, so after you calculate the test statistic, you need to find the critical value. So this is D bar. So this is all the calculation. And this is D bar. Then you need to calculate the SD. You can use calculator or Excel sheet instead of doing all this calculation, because it will take time to do all this calculation by hand. Okay, so then calculated the sample standard deviation of the difference. And this is the test statistics. I use this formula to calculate test statistics. They found 2.786 for this, for the current example. Then they found the critical value. Degrees of freedom is n-1, which is 7 minus 1, that's means 6. And you have the alpha value, so you can easily find the critical value. So T alpha over 2 plus minus T alpha over 2. So they found plus minus 1.943, and the test statistic is 2.786. So that's mean they found this. The critical value is negative 1.943, and this is 1.943. And the test statistic is 2.786. So it is somewhere here, right? 2.786 is on the right side of 1.943. So that's mean it is in the rejection region. So we reject the null hypothesis in this case. Let me see their conclusion. Yeah, we do not, they didn't reject the null in that case. Okay. So this is also paired sample. So you have the data, you have the T table. So this is also similar type of problem. So I'm not going to solve this one. So identify the variable under consideration, choose the correct answer below. So a group of 80 students were given the same standardized test twice to see. So this is also paired sample, right? Because the tests were given to the same student. So that's when this is dependent sample to see whether retaking the test affected the score. So the table gives the score improvements for 80 students. So complete parts A through E. So here the variable is score, right? Identify the two populations. So what are the two populations? So the students taking the first test and the students taking the second test. We take scores on the first test, and actually the populations are the individuals, so not the score. So scores on the first test and scores on the second test. So mean score of the first test and mean score of the second test. So now identify the two populations. Yeah, the students who are taking the first test and second test. So identify the paired difference variable and choose the correct answer below. So what is the difference variable? Difference of the score, right? So that's mean score on second test minus score on first test. And it says identify the paired difference variable. Yeah, so if you can do like this, the second test minus the first test. Yeah. So are the numbers in the table paired differences? Choose the correct answer. So are the numbers in the table paired differences? Choose the correct answer. Yes. So now at 1% level of significance, you need to do the hypothesis test. So you have to use the test statistic, which is T is D bar divided by SD over square root of N. So you have the difference. So you need to calculate the D bar of the difference and the standard deviation of the difference. And sample size N is here 8. So here N is 8. So this is the sample size because our data have only 8 observations, right? Oh no, it doesn't have 8 observations. Okay, it has 4, I think. Okay, so let me check. Actually, the data is the difference data. Yeah, so I think, yeah, 8 observations. So this is the data of the difference. Give the score improvements. Yes, this is the score improvement. So that's mean this is the difference between test 2 and test 1. So test score of test 2 minus the score of test 1. So we have total 8 observations. So N equals to 8. Okay, so then you will calculate the test statistics, and then you will find the critical value. So you'll compare the test statistic and critical value to make your decision. Okay, so the next problem is, this is also similar type of problem. Population 1, population 2. So height of father and height of son. So they also collected as a pair because father and son, right? So that's mean we cannot just collect, we cannot just measure the height of the father from one family and son from different family, right? We cannot do that because we want to compare the heights of father and heights of son. So that's mean both of them should be same family, right? For each data. So that's mean we collected the data as a pair. So this is paired sample. So this is also dependent sample. So that's mean you have to do the test statistics for paired sample. Okay, so this is also similar type of problem. And I think this is the last one. So here, preliminary data analysis indicate that use of paired t-test is reasonable. So this is also paired t-test. We have too many examples from paired t-test. So this is the confidence interval for paired sample. So that's mean the confidence interval will be then d bar plus minus t alpha over 2 times sd over square root of n. So this is the formula for the confidence interval, and alpha is here 10%. So it will be 0.10. Yeah. So you need to calculate the critical value, and then you have the data. So you have to calculate the standard deviation of the difference and the mean of the difference. And this is the sample size. So you need to plug in all the numbers and simplify it. You'll get two numbers. The smaller one is the lower bound, and the larger one is the upper bound. Okay, so that's all about the review problems. So I will stop here. So best of luck on your test. Thank you.